So this is the practice section of lesson one's note sheet. So I'm just going to run through these problems relatively quickly. As always, if you have questions or concerns, please let me know. Message me in Canvas, send me a direct email message, whatever you need to do to get some help. So problem number one, sketch the function below, describe the end behavior. All right, so this is an even degree function, which means it is going to, in this case, A is positive, so we're going to draw something that looks like that. And now that we have the sketch, we can describe the end behavior. So as x approaches infinity, in this case, we're talking about f of x, right? This is our function name. F of x is also approaching infinity. All right, our graph is increasing here. And then as x approaches negative infinity, f of x. Now, this is where a couple things can happen. If you can look at your graph, right, you can see that this graph is increasing. So as x approaches negative infinity, the graph's going up. The other thing to recognize is this is an even degree function, which means your end behaviors need to match here. So f of x is approaching infinity in both cases. So that's problem number one. I'm going to go ahead and slide over to number two. F of x is equal to x to the 35th. So that's an odd number. There's no a value or b value here to make any reflections. So odd degree functions look something like that. So when we talk about our end behavior, as x approaches infinity, f of x is going to approach. So let's see, x is approaching infinity is going to be this way. And as we move from the origin to the right, our curve is going increasing. So that means we're going to be going to infinity. And then as x, that's a horrible x, let me try that again. As x approaches negative infinity, f of x is going to approach, let's see, negative infinity, start at the origin and move to your left. And so as we start at the origin here, this curve is going to be approaching negative infinity. Okay. And again, odd degree function, these have to be mismatched. So one's positive, one's negative. Now I can't always say that they're going to match the x, right? Infinity, infinity, negative to negative, but they will always be mismatched to each other. All right, so let's see, problem number three. Problem number three is a throwback to what we've been doing since the beginning of the school year. I'm going to go ahead and subtract 11 from both sides. So x squared plus 8x minus 20 is equal to 0. Now, you could look at this and say you're going to do the quadratic formula. That is totally up to you. I'm going to factor this. So x plus 10, x minus 2. So 10 times negative 2 is negative 20. 10 minus 2 is the 8 that I'm looking for here. So each one of these factors is going to be set equal to 0, and I'm going to solve. So x equals negative 10 and x equals positive 2. So there's my two answers for number three. Sliding over to number four. Okay, so we've got a couple of functions, and we're asked to evaluate. So first thing I'm going to do is evaluate f of negative 1. And that means I'm going to use the f of x function here, which is going to include some absolute values. So every place I have an x, which there's only one of them here, but every place I have an x, I'm going to replace it with a negative 1. So f of negative 1 is equal to negative 3 times 4 times negative 1 minus 2. Now, if you have a graphing calculator or you even have pretty much any scientific calculator, you can type this thing in at once. You might have to be careful about the absolute value. So let's go ahead and do it without a calculator. And I'm going to ask you to figure out this inside portion with me. So 4 times negative 1 is negative 4. Negative 4 minus 2 is going to be negative 6. However, the absolute value of negative 6 is just positive 6. And so I want to turn this into just a multiplication problem. So that's going to be negative 18. Now I'm going to forget about f of negative 1 here for a minute. And I am going to focus instead on g of negative 4. So that means I'm going to use this g function right here. And every place I have an x, I am going to replace it with a negative 4. So g of negative 4 is equal to 2 times negative 4 squared minus 5 times negative 4. All right. So that's going to be 2 times 16. Negative 5 times negative 4 is going to be positive 20. Let's see. 2 times 16 is 32. 32 and 20 makes 52. Okay. So now that I have what f of negative 1 is, and I know what g of negative 4 is, I can take these answers and add them together. So negative 18 plus 52 is equal to just something that's not going to happen in my head. So let's go ahead and I have a calculator sitting next to me, so I just typed it in, and I got 34 as my final answer. Okay. All right, so that's problem number 4. Let me go ahead and roll on down to problem number 5 here. All right, so problem number 5, we've got a bunch of functions, k of x, m of x, and n of x. Create a new function, f of x. Okay, so let's see here. F of x equals, well, it says k of x, but k of x is x plus 1. Times m of x, well, that's x minus 4, times n of x, which is x plus 5. All right, so there's f of x, but it says to write the new function in standard form. Standard forms means I need to multiply this out. And remember, when you multiply, you are only multiplying two things together at a time. So I'm going to go ahead and take x plus 1 times x minus 4. And for this one, I'm just going to do distributive property. So let's see, that's going to be x squared minus 4x plus 1x minus 4. And then the x plus 5 still stays because I do need to multiply that later on. So let me combine up some like terms here. Negative 4x plus 1 would be negative 3x minus 4. And then x plus 5 here. And I'm not done multiplying, so I'm going to keep going. So let's see. We're going to take, I'm going to do x squared and multiply this term times both of those. So that's going to turn into x cubed plus 5x squared. Now I'm going to take negative 3x and multiply it times both of these terms. So negative 3x squared and negative 15x. And last but not least, I'm going to take negative 4 times both of those terms. So negative 4x and then minus 20. And I swear we're almost done because now we're going to combine some like terms. So I've got positive 5x squared and negative 3x squared. And I have negative 15x minus 4x. So those all need to get combined up with each other. So 5 minus 3 is going to be positive 2x squared, and then negative 15x minus 4x is going to be negative 19x minus 20. That is the standard form. Okay, lots of multiplication when we're asking you to turn it into standard form generally. So take your time, do what you need to do. If you want to put multiplication boxes in the problem and you use those, absolutely use those to multiply. All right, part B says to determine the zeros of f of x. Now, please do not use the standard form to find the zeros. Go all the way back to the first line of this problem right here, where we had all of the factors written out, because that's how I want to find my zeros. I'm going to take each of those factors. So x plus 1 is a factor, x minus 4 is a factor, and x plus 5 is a factor. And each one of those factors I am going to set equal to 0. Okay, so you are not going to be able to do this from this standard form format, so go back to the original problem. So this is going to be x is equal to negative 1, x is equal to positive 4, and x is equal to negative 5. All right, so that should be all of the practice problems on that page. Again, any questions or concerns, let me know.